Welcome to my walkthrough of the AQA June 2019 Higher GCSE Maths Paper 1, which is non-calculator. We're going to do it step by step, and let's do this. Hey there guys, welcome back to the channel. If this is your first time here and you're trying to get the best grade in maths you possibly can, let me help. Start now by subscribing. Okay then, first up, here are two right angle triangles. Circle the value of y. So, because they're both right angled and they both have an angle x, they are similar. So we need to work out the scale factor. To do that, we're going to do 15 divided by 10, which is 1.5. We then multiply that by 6 to get y. So we get 9. Number 2. Work out the value of 1 and 2/3 squared. Now that is a mixed number. To be able to square it, we need to turn it into a fraction. So 1 whole is 3/3. So we have 3/3 and 2/3. So we have 5/3 squared. Now to square that, square the top, square the bottom, so we get 25/9. Now, all the possible answers are mixed numbers, so 9 goes into 25 twice with 7 remainder, so it's 2 and 7/9. Number 3, we want to work out the arc length in meters of a semicircle with radius 6 meters. Okay, so circumference is pi times diameter. The arc length of a semicircle is half the circumference of the whole circle. So the arc length, well, the diameter is going to be 12, so it's 12 pi over 2, which is 6 pi. Okay, number 4. Circle the fraction equivalent to 4.625. Okay, bit of a strange one. So, are there any we can eliminate? Yes, the third one we know is going to be massive. So it's definitely not that one. The fourth one, if you divide something by 4, it can only end in 0.0, 0.25, 0.5 or 0.75. So it's not that guy. So it has to be one of these first two. Now, 39 divided by 8 is 4 remainder 7. So that's incredibly close to 5, so it can't be this guy. So it must be this chap. You could also prove it using the old bus stop method if you want to practice. 5a. Write 0.00097 in standard form. Okay, so we're going to need 9.7 times 10. Now because the number is less than 1, it's a negative power. Now to get the number, we need to know how many places has the decimal moved. So it's gone 1, 2, 3, 4. So it's 9.7 times 10 to the minus 4. Okay then, 5b. Work out 3 times 10 to the 5 over 4 times 10 to the 3. Give your answer as an ordinary number. Okay, so the first thing we can do is split the fraction into 3 over 4 times 10 to the 5 over 10 to the 3. Now the reason we can do that is because when you multiply fractions, you do the top times the top over the bottom times the bottom. 3/4 is 0.75. Now 10 to the 5 divided by 10 to the 3 is 10 to the 2. Now 10 to the 2 is 100. So this is 0.75 times 100, which is 75. Okay, number 6. Anna plays a game with an ordinary fair 6-sided dice. If she rolls a 1, she wins. If she rolls a 2 or a 3, she loses. If she rolls 4, 5 or 6, she rolls again. When she rolls again, if she rolls an odd number, she wins. If she rolls an even number, she loses. Part A wants us to complete the diagram with the 4 missing probabilities. Okay, so the probability of her getting a 1 is 1 out of 6. Getting a 2 or a 3 is 2 out of 6, which is 1/3. So then we got the probability of 4, 5 or 6. So the probability of getting an odd is 3 out of 6, which is a half. The probability of getting an even is exactly the same. Okay, then for part B. Is Anna more likely to win or lose? You must work out the probability that she wins. Okay, so let's write this down as P of W. Okay, back to the diagram. So, how can she win? Well, she can roll a 1 straight away. So, the first probability we want is that 1/6. Now there's another way she can win. That is by rolling a 4, 5 or 6. And then an odd number. So those are the 2 paths of the tree that we are interested in. So, we want this 1/6 first of all on its own. Now, because there is another way she can win, we're going to add on the probability of this other way. Now, the other way that she wins, probability-wise, is going to be 1/2 times 1/2. When you go along probability trees, you multiply the probabilities together. So, 1/2 times 1/2. Okay, so again, when we multiply fractions, you do the top times the top over the bottom times the bottom. So here we have 1/6 add 1/4. Now we need to combine these, so probably the easiest way is common denominators, which here would be 12. So 1/6 is 2/12. 1/4 is 3/12. Add those together and we get 5/12. Now that's less than half, so she's more likely to lose. Okay, number 7. 3 friends arrive at a party. Their arrival increases the total number of people at the party by 20%. Work out how many people are now at the party. Okay, so really this is reverse percentages. I have stuff on this linked down below. So what we know then is that 20% of the people that were there is 3. Now we can find 100% by multiplying by 5. So 100% was 15. So now there are 18. Okay, number 8, which is indices. So I've got a lot of stuff on indices, a whole playlist, and exam questions linked down below. So we want to work out the value of 3 to the 12 divided by 3 to the 5 divided by 3 squared times 3. So first up, bit maths. Sort out the stuff in the brackets. So 3 to the 12 divided by 3 to the 5 is 3 to the 7. So we got 3 to the 7 divided by 3 squared times 3 is 3 cubed. Now with indices, when you're dividing, you subtract the second power from the first. So this is 3 to the 4. Now when it says work out the value, we want the actual number, not the answer in power 4. So 3 to the power 4 means 3 times 3 times 3 times 3, which you can think of as 9 times 9, which is 81. Okay, number 9, quite a fun one. So we have a shaded semicircle inside of a circle. The radius of the circle is 10 centimeters. The diameter of the semicircle is 8 centimeters. We are asked how many times bigger is the unshaded area than the shaded area. So, quite a bit to do. We're going to need to work out the area of the circle. So let's do that. Area of a circle is pi times radius squared. So area of the circle is 100 pi centimeters squared. Now, next, we're going to need the area of the semicircle. So, careful here because we have the diameter of the semicircle. So, if the diameter is 8, the radius is 4. So, the area of the semicircle is pi times 4 squared. So, 16 pi divided by 2. So that's 8 pi centimetres squared. Now, so we now know the shaded area. What we don't know is the unshaded area. So the unshaded area is the whole circle minus the semicircle. So 100 pi minus 8 pi, it's 92 pi centimetres squared. So now we're asked how many times bigger is that than 8 pi. So to work that out, we now do 92 pi divided by 8 pi. So the pi's cancel out. We get left with 92 over 8. Now for that, we can use the bus stop. Can practice. So 8 into 9 goes once. 1 remainder. 8 and 12 go once. Remainder 4. So we put a point 0 with a point up the top. Carry the 4 onto the 0. 8 into 40 go 5 times. So the final answer is 11.5. Okay, number 10. The number of items n made by a machine in 1 hour is given by n equals 60 over t. T is the time in minutes the machine takes to make one item. The value of t changes for different items. Part A, on the grid below, draw the graph of n equals 60 over t for values of t from 1 to 4. Okay, so on the grid we have n going up side, t going along the bottom. So we want to plot values of n when t is 1, 2, 3 and 4. So for example, the first point we get is n equals 60 over 1, which is 60. N is 60 over 2, which is 30, etc. So you will then see the points do not line up in a straight line, so it's going to be a curve. Don't use a ruler, join them up freehand as best you can. Okay, then for part B, we're told the machine takes 3 minutes 30 seconds to make one item. Use your graph to estimate the value of n. So 3 minutes 30 seconds is 3.5 minutes. So we're going to go up from 3.5, hit our curve and then go across to n. So on mine it's pretty much dead on 16. You might get slightly different, and that's because your graph will be slightly different to mine. Number 11, so we have ratio. If you want more downloadable ratio past paper exam questions, there is a playlist in the description. So, Ed and Faye share £330 in the ratio 7 to 4. We're then told Ed gives Faye some of his money. Faye now has the same amount as Ed. How much money did Ed give to Faye? Okay, first up, let's work out how much they both got from the ratio. So 7 add 4 is 11. Then we need to do 330 divided by 11. Now 33 divided by 11 is 3, so 330 divided by 11 is 30. And then multiply both sides of the ratio by that, we are going to get 210 to 120. Now, for them both to end up with the same amount, they're both going to have half of 330. So they both end with 330 divided by 2. So that's 165 pounds. So for Faye to get from 120 to 165, Ed needs to give her 45 pounds. Number 12. The next term of a sequence is made by adding the two previous terms. Which of these sequences follows this rule? So, first up, minus 9 add 2 is minus 7. 2 add minus 7 is minus 5. Minus 7 add minus 5 is minus 12. So, it's the first one. Sequences playlist linked down below. Okay, number 13. The triangular cross-section of a prism is an isosceles right-angled triangle. We can see the sides are length x centimeters. We're told the volume of the prism is 102 centimeters cubed. The length is 8.14 centimeters. Use approximations, very important, to estimate the value of x. Okay, so the volume of a prism is the cross-section area times the length. Now, the area of a triangle is base times height over 2. So the cross-section area is x times x over 2, so x squared over 2. Now, again, very importantly, it said use approximations. So we don't want to be dealing with 102 and 8.14. So we are going to say that 8.14 is approximately 8 and 102 is approximately 100. So, we then know the volume 100 is equal to the cross-section area times the length. So x squared over 2 times 8. So 8x squared over 2. Okay, now, run out of room as always. So 8x squared over 2 is 4x squared. So we got 100 is equal to 4x squared. Divide both sides by 4. 25 is x squared. Square root, and we get x is approximately 5. Okay, number 14. Here is a quadrilateral with four angles, A, B, X and Y. We are told A is 90 degrees and A to B are in the ratio 5 to 3. We're then told X to Y are in the ratio 1 to 3. Our job is to show that B is equal to X. Okay, so let's start with finding what B is. So we know A to B are in the ratio 5 to 3. Now we know that A is actually 90 degrees. So what we need to do is work out how to turn 5 into 90. So we need to work out 90 divided by 5, which is 18. So to get from 5 to 90, we multiplied by 18. So we do the same thing to 3. 3 times 18 is 54. So angle B is 54. Now, what do we do about X and Y? Well, we know angles in a quadrilateral add up to 360. So we're going to add A and B and then subtract that from 360. That's then going to tell us the sum of X and Y. So 90 add 54 is 144. $360 minus that is going to give us 216 degrees. So we now know together X and Y is 216 degrees. Now we know X and Y are in the ratio 1 to 3. So now we're going to split 216 in the ratio X to Y 1 to 3. So 1 add 3 is 4. 216 divided by 4 is 54. So X is 54. Now that really is all that we needed to show. That is the same as B. Y would be 3 times 54, so 162. But the important part is that we've now shown X is equal to B. So B is equal to X. Okay, next up, cumulative frequency. So hopefully by the time you're watching this, I do have some past paper exam questions in a playlist linked down below. So, the table shows information about the test marks of 120 students. Part A wants us to complete the cumulative frequency table. So, all that cumulative frequency means is to add the frequencies together as you go here from left to right. So they've done the first two for us, 20, 48, and then we need to add 40, so we get 88. Then we're adding 20 to 108. And then we're adding 12, so we get 120. Okay, then part B wants us to draw a cumulative frequency graph. So, a couple important things. You need to know where the graph starts. So here, because in the top table, the lower bound in the first interval is 0, the graph comes out from 0 on the x-axis. Next, you use the upper bounds of each interval as the x-coordinate and the cumulative frequency as the y-coordinate. So, your points should look like this, and then you join them together again with a freehand curve as best you can, making sure you get this sort of S-shaped thing. Okay, and then part C says students who scored 15 or fewer take another test. Use your graph to estimate the number of students that take another test. Okay. So, we go back to the graph. Find 15 along the bottom. Go up until we hit the graph. So that's going to take us there. And then go across to the y-axis. So, by my graph, it's going to be about 30. Okay, then number 16, quite a tricky algebraic fraction. If you want more practice on these guys, algebraic fractions playlist down below. So we want to simplify fully 4x minus 8x squared over 12x minus 6. So the trick with algebraic fractions is to first of all factorise. So up on top we have a common factor of 4, so we'll just worry about the numbers first. So we can try the top as 4 times x minus 2x squared and then the bottom we can write as, well, there's a common factor of 6. So we can write the bottom as 6 times 2x minus 1. Now, between 4 and 6, there's a common factor of 2. So we can rewrite this as 2 lots of x minus 2x squared over 3 lots of 2x minus 1. Now up on top, there is still some factorising we can do. Inside the bracket, there is a common factor of x. So if we take that out, we get 2x times 1 minus 2x. And then on the bottom, 3 over 2x minus 1. Now, at this point, it looks like there's nothing else we can do. However, if we factor out a minus 1 on top, then inside the bracket it's going to become the same as the bracket on the bottom. So, if we factor out a minus 1, and this is the part that makes this question tricky, it's not easy to spot, we're going to have minus 2x times 2x minus 1 over 3 lots of 2x minus 1. Now the 2x minus 1's cancel, so we finally get minus 2x over 3. Okay, number 17, we have forming and solving equations. I have lots of questions on this in a playlist linked down below. So, Toby is forming and solving equations. What a hero. So, we are told that the product, so that means when we multiply together, so the product of half a number and 3 more than the number is the same as the number squared. Toby uses y to represent the number. We want to write an equation that he can use. Okay, so if y is the number, half of the number is y over 2. And 3 more than the number is y plus 3. So there's our product. Now where it says is the same as, that's where we're going to stick an equals. And then the number squared is y squared. So that would do it. Okay, and for part B, Toby forms another equation. He has x is equal to 9 over 8x. He wants to work out the value of x. Here is his working, and we're asked to point out his error. So the first thing he's done is multiplied both sides by 8x and got 8x squared is equal to 9. So that's cool. The next thing he's done is square rooted, but this is where he's gone wrong. He hasn't square rooted everything. So he should have here a root 8x is equal to 3 or minus 3. So that is his error. Although it would have been a lot better if he had gone from 8x squared is equal to 9 to x squared is 9 over 8. Square root x is plus or minus root 9 over 8. Okay, next up, here is an identity. X squared minus y squared is identical to x add y times x minus y. So it's the difference of two squares. You should have seen it before. We can use it to factorize quadratics sometimes. So we want to use it to work out the value of 193 squared minus 7 squared. So we're going to let x be 193 and y be 7. So we're going to get 193 add 7, so that's 200, times 193 minus 7, so that's 186. Now that doesn't look the nicest, so I'm going to break it down. I'm going to do 2 times 186 first. So 2 times 186. Well, 2 times 180 is 360. 2 times 6 is 12, so it's 372. We then need to multiply that by 100. And we are going to get 37200. 37,200. Part B. factorise 100a squared minus 81b squared. So again, this is difference of two squares. There's two square numbers here. The square root of 100a squared is 10a. The square root of 81b squared is 9b. So we have 10a add 9b times 10a minus 9b. Okay, number 19. Circle the fraction equivalent to 0.1 recurring. Okay, so when you have purely recurring decimals on the right, so here we do, it's just going 1, 1, 1, 1, 1 forever. It's that number over 9. So here it's just going to be 1 over 9. If you had something with two recurring decimals, so something like 0.23 recurring, that then is 23 over 99. Okay, next up, quite a tricky Selk theorem problem. Selk theorems playlist linked down below, lots of downloadable exam questions you can get. So, here, A, B and C are points on a circle. CD is a tangent. Assume ABC is isosceles with AC equals BC. From that, we then want to prove AB is parallel to DC. Okay, so first up, it is important CD is a tangent. Because of that, we're going to need the alternate segment theorem. Also in my Selk theorems playlist, you can download this PDF with all the Selk theorems you need to know. So again, we're playing with this guy. First of all though, let's deal with the isoscelesness of this triangle. So this side and this side are equal, which means this angle and this angle are equal. So we're going to call them x. From that, we know the third angle is 180 minus 2x. Okay, now, because of the alternate segment theorem, which you would want to write down somewhere, we know that this angle is equal to this angle. So this angle is also x. Now, from here, there are a few choices we can make as to where to go. So the way that I first spotted was if we extend this line, then these three angles lie on a straight line. So angles on a straight line sum to 180. So we then know 180 minus 2x add x add y is 180. So 180 minus 2x add x add y is 180. So we have 180 minus x add y is 180. Then we can subtract 180 on both sides. So minus x and y is 0. So y is equal to x. So, not 0, x. So, what does that do for us? Well, that tells us that this angle here and this angle here are the same. Now that means then they are corresponding angles, which would only work if the two lines were indeed parallel. So we've proven it. Then for part B, we are told in fact ABC is equilateral. Tick the two statements that must be true. So back to the circle first. So in an equilateral triangle, each angle is 60 degrees. Now we know that, again, from the alternate segment theorem, this angle is also 60 degrees. And again, if we extend the bottom line, then that angle is also 60 degrees. Okay. So first up, AB is parallel to CD. So that must be true because again we have the two corresponding angles, they're both 60 degrees, therefore the lines are parallel. Does AC bisect angle BCD? So to bisect means to cut exactly in half. So AC is the line going through the middle. Now angle BCD itself is 120 degrees. The line cuts that into two 60-degree angles. So yes, that is also true. Number 21. Solve the simultaneous equations 2x add 3y is 5b and y is 2x add b, where b is a constant. Give your answers in terms of b in their simplest forms. Okay, bit of a strange one. So, because the second equation tells us what y is in terms of x, we're going to substitute that into the top equation. So the top one is going to become 2x add 3 lots of 2x add b, and that is equal to 5b. From this, we can work out what x is in terms of p. So if we expand the bracket on the left, we're going to get 6x add 3p. So altogether, we have 8x add 3p is 5p. Take away the 3p. 8x is 2p. Divide by 8. X is 2p over 8. Which is p over 4. So that's x. Now to find y, we know that y is 2x add p. So y is 2 times p over 4 add p. Now 2p over 4 is half p, or p over 2. So we have p over 2, add 1 whole p, altogether then y is 3/2 p, or 3p over 2. Number 22, we have vectors, so ABC and ACD are triangles. We want to show that C to D is equal to 6A add 4.5B. So to get from C to D, we need to go from C up to A, and then from A down to D. Now to get from C to A, we're going backwards along 3B. So when you go backwards along a vector, it's negative. So C to D is minus 3B add A to D. So add 6A add 7.5B. So 7.5B minus 3B is 4.5B. So we have 6A add 4.5B. Okay, then for part B, we're told that BCD is a straight line, and we want to work out the value of K. So, by them telling us BCD is a straight line, that tells us BC and CD are parallel. Now in terms of vectors, if vectors are parallel, one of them is a multiple of the other. So, what we need to do first is work out the vector B to C. So, B to C is going to be KA add 3B. Okay, now we know that CD was 6A add 4.5B. Now, we can see then that CD is going to be the longer vector because it has the bigger B component, which means it also has to have the bigger A component. You can think of it sort of like similar shapes, where you try and work out a scale factor connecting the two shapes. We can do the same with vectors. So to work out the scale factor, we're going to do 4.5 divided by 3 which is 1.5. So to get the value of K, we then need to do 6 divided by 1.5, which gives us 4. Number 23, we have indices, so I have all the content you could ever want on indices down below. Simplified 8 to the power 4 divided by 32 to the power 2/5, giving your answer in the form 2 to the m, where m is an integer. Okay, so we don't want to work out the actual value of each part of this. We need to express each part as a power of 2. So, first up, 8 to the power 4. Well, 8 is 2 to the power 3. So we can say this is 2 cubed to the power 4. Which is then 2 to the power 12. Now 32 to the 2/5. Now to simplify things like that, we split the power. So we're going to say this is 32 to the 5th squared. Now the 5th root of 32 is 2, so this is 2 squared. So we have 2 to the 12 divided by 2 squared, which is then 2 to the power 10. Next up, f of x is sine of x minus 90, so I'll call the value of f of 0. Okay, so f of 0 is sine of minus 90. Now, if we get the sine graph out, so positively it looks like that, but we want minus 90, so we need to go backwards. It's going to look like that. Now, sine and cos oscillate between 1 and minus 1. Minus 90 is here. So the value is minus 1. Okay, number 25, we have equations of tangents. So I do have a playlist on this linked down below. So we are told P48 is a point on the tangent to a circle centre O. The tangent at B intersects the axes at point A and B. First thing we need to do is show that the gradient of the tangent is minus 1/2. Okay, so the way that we do this is to first of all work out the gradient of the radius. So O is the point 0, 0. Now, gradient is difference in y over difference in x. So the gradient of the radius, so I like to call m with a little r, is going to be 8 minus 0 over 4 minus 0, which gives us 2. Now, because a radius and a tangent are perpendicular, their gradients multiply together to minus 1. So, mr times mt, gradient of the tangent, is equal to minus 1. So here we have 2mt is minus 1. Therefore, the gradient of the tangent is indeed minus 1/2. Cool. Okay, and then part B wants us to work out the length AB, giving our answer in the form a root 5, where a is an integer. You must show your working. Okay, So what we need to do is we want this diagonal length AB. Now this whole shape AOB is a right angled triangle. So if we work out the coordinates at B and the coordinates at A, we will then have a right angled triangle where we know the height and the length. We can then use Pythagoras to work out the hypotenuse. So the first thing we need to do is work out the whole equation of the tangent. So we know at the moment the gradient is -1/2. So if we use y equals mx add c, we have y is -1/2x add c. To find the value of c, you use a set of coordinates that you know lie on the line. So here that's 4, 8. So x is 4 and y is 8. Now that's going to give us that 8 is equal to -1/2 times 4, so that's -2, and then add c. So c is 10. So the equation of the tangent is y equals -1/2 x add 10. Okay, now we know the plus 10 is the y-intercept. So the coordinates at B are 0, 10. So the height of our right angle triangle is 10. Now to find the coordinates of A, anywhere on the x-axis, y is 0. So at A, y is 0. So substituting that into the equation, we get 0 is -1/2x add 10. Add the half x, we get half x is 10. Therefore, x is 20. So, now we know the coordinates at A are 20, 0. So, now our right angle triangle looks like that. So if we call the hypotenuse C by Pythagoras, we know 10 squared add 20 squared is C squared. Ten squared is 100, 20 squared is 400, so 500 is C squared. So if we square root that, root 500 is C. Now we need to split the side. We know in our answer we want a root 5. So we can say that's root 100 root 5. C square root of 100 is 10. So AB is 10 root 5. Okay, next up, the turning point of the graph of y equals x add a all squared add b has x coordinate minus 2. 3, 1 is another point on the graph. We want to work out the y coordinate of the turning point. Okay, so from completed square form, so from y equals x add a squared add b, the turning point is at minus a b. So from this we can work out the value of a. So we know the turning point is minus 2. The turning point happens at minus a. So minus a is minus 2. So a is 2. So from that, we now know y is x add 2 squared add b. Now to find the value of b, we're going to substitute in the coordinates of this other point, 3, 1. So when x is 3, y is 1. So that's going to give us 1 is 3 add 2 squared, so 25. Add b. So take away the 25, b is minus 24. Now the final question, we have exact trig values, so if you don't know how to work them out, check out my playlist down below. It's brand new, there's exam questions in there too, so if you need them, go there. So angle x is acute, so between 0 and 90. Cos x is sine 60 times tan 30. Work out the value of x. Okay, so sine 60 is root 3 over 2. Tan 30 is root 3 over 3. So cos x is root 3 over 2 times root 3 over 3. Now, root 3 times root 3 is 3. 2 times 3 is 6. So, cos x is a half. Now, the value of x, which makes cos on the half, is 60. So, x is 60 degrees. Okay then guys, that's the end of that one. So remember, every paper so far is linked down below in the description in the same playlist. Lots of useful content down there. Make sure you check it out. If you found this useful, don't forget to give us a thumbs up, get subscribed to the channel. Take it easy, take care.